Welcome back to the channel. In this lecture series, we'll be discussing about biotelemetry. We'll discuss about what is biotelemetry, and then we'll discuss about a couple of biotelemetry devices and some vital signs in detail. So in this one, we'll discuss about what is biotelemetry and how it is relevant in our day-to-day lives. So biotelemetry is nothing but it is technology which bridges the gap between biological science and also transmission of the signal from your let's say like your device to another diagnostic system or your monitoring system and so on, and it helps monitor our day-to-day living conditions. So starting off, the biotelemetry, telemetry, it is derived from the Greek term called tele, means from remote or from a faraway location, and metron means to measure. So these two put together, telemetry means to measure from a distance. So this breakthrough in the medical industry, where previously it has to be like one to one, and the doctor and the patient have to be in the same position, same location, and they have to be there needs to be some physical contact to identify uh, biological symptoms or biological data. But with this invention of biotelemetry, it helps getting the data wirelessly and also in some cases with wired system. It enhances the let's say like diagnostic methods for the healthcare professionals and to take care of the patients. So the core components of biotelemetry systems are first off the sensors and transducers. The sensors or transducers, these helps us identify the biological signals like the heartbeat, the heart pulse, electrical signals of the heart, temperature, muscular activity, like the blood pressure, and neurological electrical signals, and all of these data can be identified or obtained through these sensors with very high precision and reliability, which is important in bio-related systems. Then comes the signal conditioners. Signal conditioners will use to obtain. I mean, what can be done using signal conditioners is that we can um, it can filter the raw data and it can take out only the things that are very required, and through and also for transferring the data, it gives the after filtering it prepares the data for optimal data transfer with higher quality and accuracy. Then comes the transmitters. Transmitters are some these are devices which help in sending the signal or receiving signal from one module to another. So in transmitters, they help in sending the conditioned data wirelessly or through wired methods through advanced modulation techniques like FM or AM, which have been already there, or digital encoding methods for reliable communication. Then, once the transmitter sends, it is received by receivers or end devices. So these receive devices, they capture the transmitter signals, convert them into understandable format, and they give us the real-time data and the real-time analysis, storage, and maybe like the diagnosis results or the decision making that can be done in the for that particular patient using the data that has been obtained. So we can broadly classify biotelemetry into two parts, as in wired systems or wireless systems. Wired systems, obviously it has wires, and since it is wired, the data transfer speeds are much higher. So that is a great advantage over here. Uh, a big disadvantage is that it has limited mobility and movement, and it cannot be taken anywhere. Probably it can be bulky as well. But its advantages are that the data transfer speeds are faster, accuracy can be very high, and primarily it is used in controlled hospital environments, and it gives us reliable data for the patients, like let's say like in-house patients. For wireless systems, mostly the wireless systems uses signals, radio frequency, satellite transmission, Bluetooth, and all of these methods to transfer or transceive data. Um, these can be mostly these are like wearable devices. Patient wear them, and it gives them full mobility. While I mean, they can go on with they may go on with their day-to-day life or within a controlled situation if it is like post-operative care. And also it can be like, let's say for example, like normal person like me who's wearing a smartwatch, we can send this data to our physician doctors if needed. Or you might have heard of like glucometers, which are like glucometer patches which are attached to your hand, which sends data in real time to your doctors. So when the value is abnormal, the doctor can either change the prescription value of insulin being sent to your body, or they can have a they can schedule a meeting or appointment with you. Then this can be used for real-time monitoring from any location, and this gives the patient much required freedom and continuous care. So biotelemetry in healthcare it is used in intensive care and emergency response. So it can give us like continuous data of it can give us continuous monitoring, and also it can give us a feedback, and it can let us know that whenever there are changes with whenever there are any abnormalities. Then comes early detection systems. Early detection systems with the addition of AI and machine learning, they can identify with even the smallest of symptoms. They can identify any probable future case issues like arrhythmias, or they can lead us to better diagnostic methods. But they can detect that there is some abnormality or anomaly there, and we have to take care of that particular anomaly and either treat it or scan much further. Then comes closed loop medical devices. These like support implantable stimulators and pacemakers with wireless communication. This eliminates infection risk from external conditions. So closed loop medical devices are like, let's say for example, if some people might have some issue with your heart pulses. The heart pulse is not proper, or it is not. It is it might be feeble, or it can be incapable of producing the signals. So for that, we can have like pacemakers, which can be implanted into your body. This pacemaker will give the much required sinoatrial pulse for the contraction and relaxation of the heart. So what happens is when there is an abnormality situation, it changes by itself because of the feedback loop.